Good morning. Today we are going to cover lesson 5-6, Inequalities in Two Triangles. This is a fairly short video, and immediately after the video I have something special. This is a video recording from 1964. It's of the animals playing The House of the Rising Sun. So I hope you do enjoy the video as well as the presentation that we're doing here for geometry today. Thank you. Good morning again. Today's lesson, lesson 5-6, is on inequalities in two triangles, and our objective is to apply inequalities in two triangles. There are two theorems that are basically the converse of one another. These are the hinge theorem and the converse of the hinge theorem. And for the hinge theorem, I want you to think of a door hinge and how it opens and closes. If you will, put the palms of your hands together and open your fingers and close them as if they were a door hinge. This is the basic concept behind the hinge theorem. But of course, we're applying these to triangles. So look at the first hinge theorem, 5-6-1. It says if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is included across from the larger included triangle. So we're just extending what we did in the previous lesson on sides and angles, where we were dealing with inequalities and indirect proofs. We're just applying it to a triangle. So if you look at angle A, the hypothesis is that angle A is greater than angle D, then the side of the triangle of angle ABC that is opposite of angle A, which is side BC, will be greater than the side opposite angle D, which is side EF. Now here's a critical difference. In the previous lesson, we were looking at one triangle and its three sides and its three angles. Here, we are comparing two different triangles, and we are finding that a similar property exists here. So let's look at the converse of the hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, and the third sides are not congruent, then the larger included angle is across from the longer third angle. So again, looking at the hypotheses, if line segment GH is greater than line segment KL on these two separate triangles GHJ and KLM, then angle J on the first triangle is going to be greater than angle M on the second triangle, according to the conclusion. Again, think of a hinge. If my angle is small in between the palms of my two hands, then the opposite side is going to be small. But if I widen the angle in the palms of my hands wider, then the side opposite that angle is going to be wider, just like opening a door. Okay? So I recognize that these two theorems, when you read them, they're difficult to understand just from the reading. But if you look at the pictures and you think of my analogy of opening up a hinge with the palm of my hands being the hinge, then I think you'll get the idea. Example A, 1A, I'm sorry, is using the hinge theorem and its converse. So here we'll apply this. Now, notice here I have a polygon ABCD. It's a four-sided figure, but it's been divided by a diagonal, a line segment AC. So it forms two triangles. BAC and DAC are two angles in those triangles, and we want you to compare them. So BAC is going to be that portion of angle A that is applied to the top part of this polygon above line segment AC, and DAC is the angle that's that part of angle A that's the part of the bottom part of the polygon where you're dealing with a triangle ADC. All right. So first we're going to compare the side lengths in triangle ABC and the side lengths for ADC. So AB equals AD and AC equals AC, but BC is greater than DC. By the converse of the hinge theorem, the measure of angle ABC is going to be greater than the measure of angle DAC. So again, you're looking at the side opposite, you're comparing the angles, you're comparing the sides. Okay, we are on example 1b. Again, we're using the hinge theorem and its converse. And in this case, we're looking at triangle EFG. And EFG has a line segment FH, and H is the midpoint of the base of the triangle EG. So that means that that portion of the base known as EH is going to be congruent to that portion known as HG. You'll also note that they've identified angle EHF as being 82 degrees. Now, do not make the assumption that FH is perpendicular, because obviously it's not. If you look at that line and you look at, of course, the degrees, 82 degrees. It's not 90 degrees. Now, what we want to do is compare EF, which is the left side of the triangle, to FG, which is the right side of the triangle. All right, and we're also going to, when we start, compare the sides and angles in triangle EFH, which is the left-hand side of the big triangle, and GFH, which is the right-hand side of the triangle. So the measure of angle GHF has to be 182 degrees minus 82 degrees. So it's got to be 98 degrees. So, we just use the principle that a straight or flat angle, which would be both of the sides of, both angles that are located at the base of EG, they've got to be 180 degrees. So if you subtract the value you know from the other, you're going to get the 98 degrees. Okay, so EH equals GH, we know that because they're both 7, and FH equals itself, FH. So what do we have? We have two sides that are congruent, and we have an angle, but we don't have both angles. But the measure of EHF is greater than the measure of GHF. Okay? But by the hinge theorem, EF has to be less than GF. Okay? So that's what we're taking back from this in terms of a takeaway. All right, now let's go to example 1c. Again, we're using the hinge theorem and its converse. So we're going to find the range of values for k. So this is similar to, again, what we did in the previous lesson, where we're finding range of values for an unknown. And we're dealing with inequalities because, again, things are greater instead of equal to each other. So if you look at the picture, you have a quadrilateral LMNP, and that has a diagonal LN. The lower side of the diagonal, the angle there, NLM, is 38 degrees, and the upper side is 5k minus 12 degrees. So we're going to find the range of values for k. So the first step is we're going to compare the side lengths in triangle MLN, that's the bottom triangle, and triangle PLN, which is the top triangle. Well, we know that LN equals itself, LN, and LM, because it says so, notice the tick marks, is also, it equals LP. So they equal each other, they're also congruent. We can use that interchangeably in this case. But MN is greater than PN. Okay? So by the converse of the hinge theorem, the measure of angle MLN must be greater than the measure PLN because MN is greater than PN. So substitute the given values for the measures of angle MLN and PLN, and you get 5K minus 12 has to be less than 38. Now add 12 to both sides and divide by 5. Simple algebra. And you get K equals 10. So if you want to, in fact, we're going to do that next, we're going to then substitute K into the expression. Okay, in step 2, we're going to do the next combination. Since angle PLN is in a triangle, the measure of PLN has to be greater than 0 degrees. So we're going to substitute the given values. And so we're going to say that 5K minus 12 is greater than 0. We'll add 12 to both sides and divide by 5, and we're solving. And we get K is less than 2.4. So you see we're going to develop a range here. Step 3, combine the two inequalities. So the range of values has to be for K. 2.4 is less than K, which is less than 10. Okay, now you're going to check it out. This is a problem you're going to do. You've got a quadrilateral here. It's been split into two triangles. So compare the measure of EGH and the measure of EGF. Tell me what sides and angles should be. And you can stop the video, of course, to do that. And then when you're going to move on. All right, and now you're going to next compare BC and AB. Those are line segments in this triangle ABC that has been split into two triangles, ABD and DBC. So again, stop the video, go ahead and do it. You're given quite a bit of information there. You should be able to use the hinge theorem to solve for sides and degrees that you don't have. All right, now we're going to do a travel application. And so we're using the same principles, we're just applying it to a map example. John and Luke leave school at the same time. John rides his bike 3 miles west and then 4 blocks north. Think about this as if it were on a XY coordinate chart, and it kind of gives you some idea of how the grid works. Luke rides 4 blocks east and then 3 blocks at a bearing of north 10 degrees east. Well, that's an angle. So think about that. Who is farther from school? And then, of course, you have to explain it. So let's see how we do it. So the distance of 3 blocks and 4 blocks are the same in both triangles. In other words, the distance for the blocks. The angle formed by John's route, which is 90 degrees, is smaller than the angle formed by Luke's route, which is 100 degrees. So Luke is farther from school than John by the hinge theorem. So again, you're just looking at the angles and you say, oh man, okay, then the distance between John and school has got to be less than the distance between Luke and school, simply because of the measurements of the angles. Very simple. Okay. So now you're going to do one on your own. This is about a swing ride, but you'll notice we've created triangles by the motion of the swing. So when the swing ride is at full speed, the chairs are farthest from the base of the swing tower. What can you conclude about the angles of the swings at full speed versus low speed? So if at lower speed, what do you think is going to happen? At higher speed, what's going to happen? What's it going to do to the angles? And what's that going to do to the distances? That's the sort of thing you're explaining. Okay, you can stop the video again if you need it to do the work, and then you can move on. All right. Now we're going to prove triangle relationships, and I want you to write a 2-column proof here. So here we have a quadrilateral ABCD. It has diagonal BD, so the quadrilateral is divided into two triangles, and you'll notice that AB and CD are congruent. Now, if you'll remember, when you have congruent sides like that, you can deduce some things about what the quadrilateral is. But the given is that AB is congruent to CD, and the measure of ABD is congruent to the measure of CBD. So if you know that, you should be able to prove that AB is greater than CB. So now we're going to do the proof. So set it up into statements and reasons. And so first you do your given. AB is congruent to CD, and the measure of ABD is greater to the measure of the angle CDB. That's your given. Now, you're going to use the reflexive property of congruency to say that, hey, BD is congruent to BD. That's the diagonal. Then you're going to use the hinge theorem. And you're going to say that AD is congruent to CB. And the reason, of course, is because, again, the angles that are opposite them are also going to be congruent. All right, we're going to do a second one, but this time you're going to do it. So you have a quadrilateral here that's divided into 3 triangles. And you'll notice that you've got 4 angles identified, and you're given that C is the midpoint of BD, the top line, and that the measure of angle 1 equals the measure of angle 2, and the measure of angle 3 equals the measure of angle 4. Okay? So you're going to prove that line segment AB is greater than line segment ED. Take some time, look it over, and go ahead and write out your response, and then you can move on. Go ahead and stop the video if you need to. All right, and of course this is where you do your statements and reasons. We'll move on. All right, so now you are going to do your own 2-column proof, and we have a 4-sided quadrilateral figure here. Looks kind of like a kite. And you'll notice that angle STR is congruent to angle SRT. And they also tell you that line segment TU is greater than RU. So you must prove that the measure of angle TSU is greater than the measure of angle RSU. You're doing this as a proof. Okay? So please go ahead, stop the video if you need to. This also happens to be the last slide in this particular series. Put together your answer, and with it you are done, and I hope you have a wonderful weekend, and we will see you next week.
children